All right, so once again, morning everybody. Let's just do a quick recap. Hopefully you would have downloaded that document, differential equations from on Canvas. So we're just going to go through that quickly. All right, so again, just in case of internet issues, right, this document is very important. If you understand the concept in this document, then what you do is follow this guide and all the examples, all right? And that's it. All right, so we had differential equations, all right? And we said that it's simply a relationship between an independent variable and a dependent variable. Now, those two we are accustomed to, and we call them algebraic equations. Y is equal to x, or x squared, or x cubed, and so on. But with a differential equation, it involves dy dx, or d2y dx squared, or even d3y dx squared, and so on, dx cubed, and so on. All right? So this particular differential here will determine the order of the equation. So in this first example here, we only have dy dx, so it's a first order. In the second one, we have d2y dx squared and dy dx, but it is the highest one that matters. Okay, this little section had shown us how differential equations come about, but again, you will not be asked to form differential equations. So, right, this is just for your understanding. And then we went into and the first method, which was direct integration. And direct integration is what we did a lot of in Maths 2. And this was just an example here. All right. So once again, if you see dy dx and you're asked to solve, basically you're asked to find y, which means that you have to integrate both sides. All right. The second method we looked at was called the separation of variables. In other words, we have dy dx, but on the right-hand side, we have a combination of x and y, right? So it is an equation with a function of one or more of its derivative, right? So in a case like that, we do what is called separating the variables, all right? Which means that anything that involves x must go on the right, and anything that involves y goes on the left. And then we had some examples, and we did quite a few of those examples. Now, what happens here with this particular method is that it brings your algebraic skills into play, meaning you have to know how to move things around. If it's on top, it has to go underneath. If it's underneath, it has to go on top. If there is a plus and minus, you have to be careful. You might have to move the entire thing. Or if it's plus, you carry it on the next side, it's minus. And if it's minus, when you carry it across, it becomes plus, and so on and so forth. So we have some examples here, etc., etc. So you put all the y's on the left, all the x's on the right, and then you integrate both sides. All right, so we did quite a few of these. All right, so it's up to you to revise them. Take a look at, we did a number of examples to get you familiar. All right, in some of these, you will see that they go a step further, right, than where we stop. For example, they have ln y is equal to kx plus a and so on in one of these solutions, and they simplified it by taking e and so on and so forth. For our, you can go through it and try and understand it, but for examination purposes and so on, when you can stop up here, right? Or even here. You don't need to go further and remove ln and e and all that kind of stuff. But you'll see it in the examples anyhow. All right, so those were just real life applications. We're not too bothered with that. You have some examples. Right. You have a harder example. And all of these I think we did. So you shouldn't have any problems. All right. The second method that we looked at was called homogeneous differentiations or subsets. So in this case, we have equations of the form dy dx is equal to f of yx. Here, we have a combination of x and y on the right-hand side, but it's not easy to separate them, or it's almost impossible to separate them to get the y's on the left and the x on the right. All right. One of the, hopefully you have this in your notes, one of the conditions for using homogeneous, well, two conditions, and the first one is that if you're going to apply it, then there must only be dy dx on the left. All right. And the second one is that the degree of x and y on the right-hand side must be the same. So if we go down to this example for it here, dy dx is equal to x plus 3y over 2x. The highest degree of x in the right-hand side is 1, and the highest degree of y on the right-hand side is also 1. So therefore, the method will work. What is the method? The method is to make a substitution. Wherever there is a y, we're going to put vx. And you got to understand that, because this is where most people make a lot of mistakes in their substitution. All right? And so check the examples and see. Whenever you're making the substitution, please use brackets so that you don't put square and all that kind of stuff in the wrong place. So once we are going to substitute y is equal to vx, then that immediately, based on this differentiation here, it immediately tells us that we will also have to substitute dy dx is equal to v plus x dv dx. All right? So this is the line that is what we want. So the trick is, on the right-hand side, wherever there is a y, we are going to put vx, and we are going to replace the left-hand side with v plus x dv dx, all right? And those would be in our examples. So now for this equation here, the left-hand side becomes v plus x dv dx, and the right-hand side becomes x plus 3 multiplied by vx. In this case, it's just, we could have used brackets, but it's 3 multiplied by, so it's not a problem. Okay, now we got to manipulate the right-hand side. The idea behind the substitution, especially on the right, is we're going to figure out that all the x's will disappear on the right-hand side. If you look at all the examples that we did and do, you will see that the idea is to get rid of x from on the right-hand side, and we'll only end up with v. So now that we have only v on the right, we need to get rid of this v from on the left. So we are going to end up with x dv dx on the left and only v on the right-hand side, 1 plus v plus 2, over 2. Again here, you have to understand that when you bring across the minus v, every time you are going to have to take the LCM, because this is the same thing as v over 1. Again, look at the examples we did, and you take the LCM and simplify this here, which gives us 1 plus v over 2. Now, the next step, remember this, the next step is to separate the variables, just like we would have done with method 2. All the x's go on the right, and now all the v goes on the left. So then we end up with this line here, the integral of 2 over 1 plus v dv is equal to the integral of 1 over x dx. And in almost every case, we'll end up with ln x on the right-hand side, because it's the integral of 1 over x. On the left, you got to be careful. Remember, that if you see that the numerator is the differential of the denominator, then you can use ln. Otherwise, you have to use your integration skills. All right. And then, of course, we get to this answer here, 1 plus v squared. Well, this line here, as I said, is extra. This is the line that we can stop at. right, for examination purposes, 2 ln 1 plus v, because that's the integral on the left-hand side, is equal to ln x on the right-hand side plus c. All right? Okay, they just replaced c with ln a here to make the entire equation ln, and then they can remove the ln, right? Because if ln a is equal to ln b, that means a is equal to b, and stuff like that, and you have to go back to your log days to realize that. But if we stop on this line here, then remember that we cannot leave v in our answer, all right? We have to replace v from our original substitution. Y is equal to vx, therefore v is equal to y on x, all right? And that's what we're going to substitute here. So wherever there is a v now, we'll replace it with y on x, okay? And so we would have done that here and, well, up to here, sorry. Right? We just replace the v here, and that will be our answer. All right? Okay, so don't let this, the little manipulation here confuse you. All right, so now we're going to go into method 4 before we get to this part. So we will come back to this little page afterwards. Let's see how to apply all of this drama before we go to that page. So, all right, just give me a second to get organized here. All right, so we are going to be looking at method 4. Right, and these are called linear equation or rather use of an integrating factor. Okay, all right, so we're going to see we're going to see how we arrive at this, okay, before we actually jump into applying it. So try and stick with me a little bit and see if you can understand the concept, all right? If you understand the concept, then applying it later on becomes a lot easier. All right, so you may want to write what I'm going to write here now. I don't think I put this in the notes. All right, so consider dy dx, sorry, plus 5y is equal to e to the 2x. Okay, so trying to separate variables or substituting y is equal to is not going to help us. So therefore, we introduce this new method. All right. First of all, it's clearly an equation of the first order. All right. And the first condition is that, again, there must be nothing in front of the dy dx. All right. This is on the left-hand side. That's fine. Doesn't matter what else is on the left-hand side. It's just that dy dx must be by itself. So for example, if they had an x here, we had to move this x from here. All right, we'll see that a little later. All right. Now, this is not the method, all right? This is to show you how we arrive at the method. So this is clearly an equation of the first order, but it's different from what we have so far. All right, let's multiply throughout by e to the 5x. All right, so therefore e to the 5x dy dx plus y by 5 e to the 5x. Okay, that's just here, all right? I just put the y in front of the 5. All right, y you'll see just now. But I could have simply written 5y e to the 5x. All right, and this is equal to e to the 2x by e to the 5x. Okay. All right. If you multiply an equation by the same value or divide it or do anything to this, both sides of an equation, you don't really change the equation. So for example, if we say 2x is equal to 4, then x is equal to 2. But if we multiply both sides, we're going to get 4x is equal to 8. All right, let me write that so you understand the concept. 2x is equal to 4. If I multiply both sides by 2, then I'm going to get 4x is equal to 8. We have not changed the equation. X is still 2. Okay? All right. So what we just did in green is not change the equation. We just rewrote it in a particular way. No. If we look at the left-hand side, which is this here, right? Again, you may not realize it, but this is what will have happened. All right. D dx of y e to the 5x, all right, from our differentiation days, is equal to e to the 2x. All right. So from that, therefore, y e to the 5x is equal to the integral of e to the 7x dx. Oh, sorry, this is supposed to be 7x. Right? So in other words, we integrate both sides. Right? So the differential of y e to the 5x will give us e to the 7x. Okay? We integrate both sides with respect to x. All right, and we get y e to the 5x, right? Because when you integrate, this will disappear. And then we integrate the right-hand side, so we get the integral of e to the 7x dx. All right? All right, so hopefully you have this, right? I'm going to go to another page. All right, so our next line reads, therefore y is equal to e e to the 2x on 7 plus c e to the minus 5x. Okay? What really happens here is this. This e to the 5x, we're going to divide everything by it. All right? This here, of course, is e. Sorry, I missed out a line. So let's do that. Let's not miss out the line. Okay, so after the last line that we had here, which is y e to the 5x is equal to the integral of, therefore y is equal to, sorry, y e to the 5x would be equal to e to the 7x on 7 plus c. We integrate the right-hand side. All right, now we're going to get rid of this e to the 5x here from on the left. So therefore, y is equal to, when this go on this side, is going to be divided. So you subtract the powers. So we're going to get e to the 2x over 7 plus c over e to the 5x. Bring that on top. Okay? And that's it. All right. What we have to remember here, you see this? That's a constant, right? We apply the constant right after the integral. But you see, when we move in this e to the 5x, we have to include it with the constant. That's why I get this here. You can't just say, okay, let's replace this with a bigger constant to another constant. You can't do that, right? Because there is an x involved. All right. Okay, so what is the purpose here now? The equation we have just solved is an example of a set of equations of the form dy dx plus p y equals q. All right. So this is what we are looking at, what is called a linear equation using use of an integrating factor. So method 4 requires that our equation be in this form. So the example that we looked at was this here, which is dy dx plus py is equal to q. Which means that where P and Q are functions of X or constants. Right? Because in the example that we just did, okay, this is P is 5, which is a constant. All right. And this here is Q, but Q is a function of X because it's e to the 2X, okay? All right. Now let's take a look at how to solve equations of this form. Okay. All right. So if you finish with this page, I'm going to go to another page. All right. It looks a little bit complicated. Don't worry. When we apply it, just now I'll simplify the whole thing for you. But it's important that you understand the concept so that you don't run into difficulties later on. All right. So let's move on. So to solve, just give me a second. Okay. All right. So technically, right, to solve dy dx plus py equals q, we multiply both sides by what is called integrating factor. Okay, e to the integral of p dx. All right, this here is the integrating factor, e to the integral of p dx. All right.
Just doing the function.
All right, so let's do an example. Okay, and then we'll switch and I'll show you it in simplified form. Okay, so we're going to do a number of examples. Example 1. All right. Okay, after example 1, I'll generalize this whole thing for you and you'll see how easy it is. All right, so it says solve dy dx minus y equal to x. Okay. All right, remember it must be in the form dy dx plus px, sorry, py equals to q. Must be in that form. All right, so dy dx, that's fine. Py, this is y. So what do you think is p? All right, p is going to be minus 1. Whatever is in front of that y is p. What is q? In this case, q is x. All right. All right, so remember what they said. We have to multiply both sides by the integrating factor. So here, we got to figure out what our integrating factor is. So your first task, what I would normally do is just simply write down quickly what is P and what is Q. We're beeping, but I don't know why. Is anybody trying to get back in? All right. Okay. So once we do that, right, remember this is our integrating factor here. Good. All right. So integrating factor is e to the integral of p, which is minus 1 dx. Okay? Right, which of course is equal to e to the minus x. All right, forget the plus c. We don't need that at this stage. So this is our integrating factor here. Okay, so now they say multiply both sides by the integrating factor. So therefore e to the minus x dy dx minus e y e to the minus x is equal to x e to the minus x. Okay, everybody understand that? This is the integrating factor. We have to multiply everything here by e to the minus x. So e to the minus x dy dx, and then minus y by e to the minus x, and then x by e to the minus x. Okay. All right. If we had understood this multiplication here and what we created here and what happened here, right? When we multiplied the entire thing by e to the 5x, what happened to our left-hand side here is that that is the same thing as this. Okay? So by multiplying by that particular value, e to the 5x, right, and how we come up with e to the 5x in this example, right, is we found the integrating factor, which was e to the integral of, e to the integral of 5, right? So we got e to the 5x. And then, so when we multiply the left-hand side, we ended up with the differential of y e to the 5x, which is this here, except the 5. All right, so that's what we are doing here. So therefore, d dx of now, there's no particular reason for using the curly brackets. E to the minus x y is equal to x e to the minus x. Okay? So by multiplying this by our integrating factor, we end up with this. but that is what we can rewrite as this. Okay? Again, if you differentiate this, you're going to get this here. But don't worry, you won't have to do that. It's going to be the same thing every single time. All right? So then continuing from here, hopefully you have this line. ddx of e to the minus xy is equal to, all right, our next step, therefore, is to integrate both sides. So therefore, y e to the minus x is now equal to the integral of x e to the minus x dx. Okay? All right, that's basically integrating both sides. Remember, we'll get rid of this, and we'll end up with that, which gives us this here, which means that we have to integrate the right-hand side. All right. Of course, to integrate the right-hand side, anybody? You have to integrate this by parts, because it's a multiply sign there. Okay, we're not going to go through integration by parts right now. You can do that. Which basically is going to work out to be u v minus the integral of v du. Okay. All right. Okay. And therefore, y is equal to this e to the minus x have to go on the next side. All right. So we have to divide everything on the right-hand side by e to the x minus x, sorry. Everything must be, right? Because on the left, we're going to divide it by e to the minus x, which cancels. So that leaves us with y is equal to minus x, right? The e to the, that will cancel. This will cancel. Minus 1 plus c e to the x, right? When we bring this on top, there's nothing to cancel here, so we bring it on top. All right, and of course, if it's maths you're doing, then y is equal to c e to the x minus x minus 1. Okay, all right, so let me generalize all of that for you, and then you can simply apply it in all the different examples that we're going to do. So here we go. Okay, so for dy dx plus px equals q, right, where p and q are functions of x, integrating factor equals e to the integral of p dx, and therefore dy dx by y e to the integral of p dx is equal to q by e to the integral of p dx. Okay, my mistake again. This can't be y here. Actually, it is. So let's write this. Let's do this back. I don't like what I just did here. I want you to understand it. So, therefore, right? Once we found the integrating factor, as we saw earlier, we multiplied everything by it. Multiplied by e to the integral of p dx plus px multiplied by, sorry, where I get this x from? Oh boy, what's wrong with me this morning? Right, so for dy dx plus py equals to q, our integrating factor is e to the integral of p dx. We multiply everything by e to the integral of p dx. So we're going to get dy dx by e to the integral of p dx plus py by e to the integral of p dx is equal to q multiplied by e to the integral of p dx. All right, and we know that this side is as a result of the differential of y e all right, and when we integrate both sides, right? So, all right, I'm just going to go to the top. So therefore, y times the integrating factor, right? If you look here, right? I'm just using if instead, just so that you see. Is equal to the integral of q times the integrating factor dx. All right, and that's what we need. Okay, so I'm going to generalize all of that for you. All right, so for dy dx plus p y equals to q, then y times the integrating factor is equal to the integral of q times the integrating factor dx, where integrating factor is equal to e to the integral of p dx. All right. Okay, so this is what we need. Write on that. For dy dx plus py equal to q, then y times integrating factor is equal to, all right. Okay, so let's see. Let's see if we can get it mastered. Dy dx plus 3y is equal to sine x. Okay, all right, let's identify. P is equal to 3. Q is equal to sine x. And our integrating factor would be equal to e to the integral of 3 dx. All right, so far so good. All right, so this is the technique. All right. All right, we have, this is method 4. Our equation is a linear equation in the form dy dx plus 3y is equal to px. We identify p is 3, and don't forget it will always include the sign as well. Huh? Okay. All right, and q would be sine x, and our integrating factor is, which is equal to the integral of 3 is e to the 3x. Okay, so that's our integrating factor. Now let's go back to the formula. Our answer is going to be y times our integrating factor is equal to the integral of q by the integrating factor dx. All right. Okay, of course, in this particular case here, leave this because that is integration by parts. And you're going to go back to that and you'll have to do it a few times because this is one of the examples we have done integration by parts. So go figure that out. All right, but it's not going to come as complicated like that in exam. So let's take a look at some examples now. All right, so everybody understand the substitution? It's very simple. Once we have this, we identify what is P, what is Q, we find the integrating factor, and then we write this line. So your trick here now is to just work out this integral here. Okay? All right, so let's do some examples then. Okay. All right. So is it in the form? All right. No, it's not. All right. Remember, it has to be dy dx plus py equals q. All right. In this case, we have an x here. So we have to get rid of that x. All right, which means that we'll divide everything by x. By x, by x, by x. All right, so it's the first divide through out by x. So therefore, dy dx plus y over x is equal to x squared. All right? All right, so let's do our stuff. P is equal to 1 over x. All right? Remember, it is everything surrounding this y. All we want is the y alone to remain, take everything from there. So y over x plus, right, is plus 1 over x multiplied by y. So we're going to grab this here. But it's plus, so we leave out the plus sign. All right? Q is equal to x squared. All right? And integrating factor is equal to the integral, e to the integral of 1 on x dx. Okay? Which is equal to e, the integral of 1 on x is ln x. All right? But remember, e is the inverse of ln. All right? So if you work out ln 5, the answer that you get, if you work out e to that value, you're going to get back 5. All right? So it's the reverse. So in other words, the e and the ln will cancel here, and we're going to get x. Okay, and now we apply the formula. So therefore, y times our integrating factor is equal to the integral of q by the integrating factor dx. In other words, therefore, yx is equal to the integral of x cubed dx. All right? So I'm going to go up here now. All right, so let's go up here. So therefore, yx is equal to x4 on 4 plus c. Right? Once you do the integration at this stage, you have to put the plus c. Okay. And therefore, y is equal to now x cubed on 4, because this x here going on the next side, so when we divide, it will cancel with one of this here. Plus c over x. All right, that must be left as is. All right. Okay. Unfortunately, life doesn't stay as simple as that. So let's go do some more examples. So far so good, everybody. Anybody having any questions?
No, sir.
Okay, great. Thank you. Okay, so let's continue then. Okay, the concept, the principle remains the same. It's just that the little integration and stuff is going to get a little bit more complicated. So let's see. Example 3. But more often than not, don't let it confuse you. All right. Solve dy dx plus y cot x is equal to cos x. All right, so that is in form that we need p is equal to cot x, right? It's plus, and whatever is around the y. Q is equal to sin cos x. And therefore, our integrating factor is e to the integral of cot x dx. Okay. All right, however, but the integral of cot x dx is really the integral of okay, so you see where you're going to need your integration skills, all right? All right, we would have done this example in integration. Well, I'm not sure if you were in the integration class, but this is the same thing as cot is cos x over sin x dx. All right, And in this case, the numerator is the differential of the denominator, which our answer therefore is ln sine x, right? Plus c, but forget the plus c. So therefore, the integrating factor is equal to e ln sine x. Right? Once again, that e and the ln will cancel, which means that our integrating factor is sine x. Now, not every time the e and the ln, there'll be an e and a ln, all right? So don't fall into that trap. More often than not, but not necessarily all the time. So if you don't see it, don't panic. Okay, so now that we have the integrating factor, we go straight into our substitution. So therefore, y times the integrating factor is equal to the integral of q by dx. Okay, and again, this is integration that we can do, remember? Okay, like this, for example, was f dash x over f of x. The integral, when that happens, remember it's ln the denominator. And when we have it as f of x multiplied by f dash x dx, the answer is always f of x to the n plus 1 over n plus 1. All right, so therefore this works up to be, the integral of that is sine x squared on 2 plus c. All right. All right. So you realize that the hardest part of this is to revise your integration. All right, and therefore, so sorry about that, but let me get rid of some of this stuff here. Okay, and again, remember we want y. So therefore, y is equal to sine x on 2 plus c over sine x. Right? We have to divide everything by that sine x. It will cancel with one of this here. Right, so really our answer is c cosec x. That's 1 over sine x. All right, so again, as I said, in examination purposes and so on, don't panic. Just go through the steps, identify what is P, identify what is Q, figure out your integrating factor, make your substitution, and then if the integration eludes you, at least you'll start getting marks. Understand? So don't give up on it. It shouldn't be that hard anyhow. Okay, now let's make it, let's see. Okay, so let's keep going. We'll do a few more. And then we'll go to some past paper questions. All right, so let's see. Example number 4 says solve right. Don't forget, it must be in the form dy dx plus py equals to q, which means that we got to get rid of this x plus 1 here. All right. So that's the first thing that we will do. So therefore, dy dx plus y over x plus 1 is equal to x plus 1 squared over x plus 1. So therefore, dy dx plus y over x plus 1 is equal to x plus 1. Therefore, P is equal to 1 over x plus 1. Q is equal to x plus 1. Integrating factor is e to the integral of 1 over, which is P. All right, which again works up to be e ln x plus 1, which of course is x plus 1. Right? All right. So now we're going to go to our substitution. Y times the integrating factor is equal to, so therefore y x plus 1 is equal to the integral of x plus 1 by x plus 1 dx. Okay. All right, and of course, to integrate the right-hand side, we can spell this out, remove the brackets. So therefore, y x plus 1, so the x cubed on 3 plus x squared plus x plus c. Okay. And in a case like this, we will leave our answer like that because to bring this x plus 1 on this side means that it's just going to get very, very, very tricky. Okay. Now, I'll show you another trick, however. if you're on top of your integration game, this would be what we are accustomed to. All right. So this step here would have been what we are accustomed to. We just expanded and so on and so forth. But we could have written this as all right. We just write it back as x plus 1 squared. Okay. And if you're on top of your game, then this is x plus 1 cube over 3 plus c. Okay. So we could have gone in this direction instead of here. But it doesn't matter, again, for examination purposes, whichever way you go. All right. Okay, so far so good. All right, let's do another one. This, I think, is number 5. So we want x dy dx minus 5y is equal to x to the power of 7. All right. So I'll give you a minute. You go ahead, and then I will come along afterwards so that you can double check. All right, so first things first, we have to get rid of that x. All right, again, go ahead and work. Don't wait to copy unless you came in late. So. All right, P would be minus 5 over x. Don't forget the minus sign. If you do, it's going to be wrong. E to the integral of minus 5 over x dx but the integral of minus 5 on x dx is minus 5 the integral of 1 on x dx, which is equal to minus 5 ln x. Okay. So therefore, the integrating factor is equal to e to the minus 5 ln x. All right. Okay, but again, you remember from your log days, the log of x squared is 2 log x, right? Remember the power goes in front, right? And similarly, we could do the reverse. Which is equal to e to the ln x to the minus 5. Right? The power goes on top here. Sorry, the minus 5 goes as a power. Now the e and the ln can cancel. You could not cancel this e and this ln here, right? Because of the minus 5. So then this is equal to, oops, x to the minus 5. And that is your integrating factor. If you want, 1 over x to the power of 5. So now we're going to substitute. So therefore y times 1 over x to the power of 5 is equal to the integral of q, which is x to the power of 6, by 1 over x to the power of 5 dx, which is the integral of x dx, which is x squared on 2 plus c. Right? I'm just going to put it up here in red. So therefore y is equal to x7 on 2 plus c x to the power of 5. Okay, got that? All right, that's because this x to the 1 over x to the 5, that x to the 5 I'm multiplying throughout by that. So I have to multiply this by x to the 5. So I'm going to get x to the 7. And I have to multiply c by x to the 5. I can't just leave it out. I have to multiply by this c. Okay. Okay, so let's do a couple more and we take a little break. And then we'll do some past paper questions. All right, so number 6. All right, now it's going to get a little bit rough, all right? Number 6. 1 minus x squared dy dx minus xy is equal to 1. All right, so go ahead. right? P is minus x over 1 minus x squared, everything that is around the y. And the integration factor is e to the integral of 1 over okay. Again, the integral here is all right, forgot the x. All right, now we got to go integrate that. All right. But remember, this is the same thing. You see, we need a 2x on top, but we only have 1x. Because if we differentiate the underneath, we're going to get 2x. So if I put minus a half, see? So once the numerator becomes the differential of the denominator, we use ln. Okay. So therefore, our integrating factor becomes e to the minus a half ln 1 minus x squared. Again, we have to get rid of the half before we can eliminate the e and the ln. So it's going to be e ln 1 minus x squared to the power of a half, which is minus a half, really. Oh boy. Okay. Sorry about that. I'm making a mistake here. All right, I forgot. You see how easy it is, right? To make mistakes. Look, I forgot this minus sign here. That is why I was wondering why on earth I'm getting this half here. So this really should be minus. Okay, so fix it, please. Let's go back up to this line. Let's start back from the top. The integral of 1 minus x squared dy dx minus xy equal to 1. We know we have to get rid of the 1 minus x squared. All right, so we divide everything by 1 minus x squared. And then this here, see, I have to remember to take this sign. That is going to be p. Q is this on this side here, that's fine. But the integrating factor is e to the integral of minus x over 1 minus x squared. All right, but the integral of minus x, in this case, I will not need this minus sign here. I already have the minus sign. So what I really need was the 2. So I put the 2 and take out back the 2, which means that we don't need this half here. That minus. Sorry. Okay. All right. Which is equal to 1 minus x squared to the power of a half. That's our integrating factor. All right, so far so good. Okay, so let's finish it up. All right, so I'm going to the next page. So therefore, y times the integrating factor, which is 1 minus 2x to the half, is equal to the integral of q and the q was 1 over 1 minus x squared by our integrating factor, hold on, I'm doing something wrong again. Let's go back. What did I do wrong here? Okay, it's 1 minus x squared to the half. See, I'm not seeing pages as you would see it. I only see one little piece at a time. Okay, so it's 1 minus x squared to the half. Okay. Everybody got that? Okay. So hopefully you can see this. Let me see. Let me show you it separately rather. This is 1 over 1 minus x squared multiplied by 1 minus x squared to the half. Okay. Now, if I had 1 over x by x to the half, all right, let's do that a different way. If I had 1 over x squared multiplied by x to the 1, we know we can cancel and we'll get 1 over x. Similarly here, we can cancel and I'm going to get 1 over x to the half. Right? So therefore, this becomes 1 over 1 minus x squared to the power of a half. So therefore, on top here, this becomes the integral of 1 over 1 minus x squared to the power of a half dx. Okay. All right. As I said, the integration part is the hardest thing. All right, but we'll take a look at passivers and you see it wouldn't come as hard as this. So, all right, this is the same thing as the integral of 1 over 1 minus x squared. I'm going to write it in a form that you will recognize. All right, and that's a formula. You go to your integration formula worksheet. So, sorry, formula sheet. You will get that that is equal to sine inverse x plus c. Okay? And we'll leave our answer like this. Right? It makes no sense bringing this square root across. It's just going to go underneath and create confusion. Okay. Right. If you're interested, this is here to do that rather than from the formula sheet. You'll have to make a trig sub integration, and you're going to use u equals sine x, etc., and you'll get sine inverse x as your answer. All right, let's do last one, and then we take a little break. Okay, this is going to be along the same lines, so you can follow the same steps. Integration would probably be this, well, wouldn't be as would be. So this is number 7, I think. So it's x minus 2 dy dx minus y is equal to x minus 2 cube. All right. Same strategy. Dy dx minus y over x minus 2 is equal to x minus 2 squared. All right, because when this comes on this side, it's going to cancel. So P is minus 1 over x minus 2. Q is equal to x minus 2 squared. Integrating factor is equal to E, the integral of minus 1 over x minus 2 dx. All right, keep going. But right, remember we had to get rid of this minus sign here first, all right, before we could eliminate the E and the ln. Okay, and that's going to be your integrating factor. Right, so finish it up. You just have to substitute, and you'll see how easy it is. All right, the substitution and the rest of it is easy. Finish it up, and then we'll take a break, and we'll start back at 10 o'clock. Here we'll do some past paper questions. Let me find them. Right, be back shortly. All right, so let us resume. All right, so we're going to tackle some possible questions. Before we do, let me just share that list with you so we can just quickly make sure everything is there. All right, so method 4 to solve a differential equation of dy dx plus py equal to q. All right, so y times the integral of y times the integrating factor is equal to the integral of q integrating factor dx, etc., etc. All right, so your notes have it complete. All right, so let's go do these possible questions. All right, one of the things about the possible questions is that you'll have to figure out which method to use. Sometimes they will tell you, sometimes they will not. If they don't, you'll have to figure it out. Okay, so you got to watch the questions carefully and then decide. Normally, method 4, which is the linear equation, integrating factor, is kind of easy to figure out. But it's the other two that you'll have to spend a minute or two and try to figure out which method you're going to use. Okay, and they do not necessarily put it in order, meaning method 2, 3, and 4. So you got to be careful. So let's take a look. We have this question that says dy dx solve 2y okay. So the first thing you have to figure out is which method are you going to use. All right, it's I think it's a 2019 question. I have it all mixed up, so It's 2019 sometime. Right, so the first thing you have to figure out is which method you're going to use. We realize that it's not method 4, so we can eliminate that. So it's either going to be we can separate the variables or we'll have to substitute. Now when we look at this, we realize that, hold on, this is x, so that's staying right here. We don't have to worry about that. But this 2y, because it is a multiply sign here, we can move it. So this seems to be pretty straightforward. So we can separate the variables. So therefore, 1 over 2y by dy dx, right? And I'm spelling it out. You can skip this step if you want. Okay. All right. Now we need to get rid of the dx here. Okay. And of course, this on the side here is the same thing as saying 1 over 2 by 1 over y dy. You can write it anyhow you want. 1 over 2 by dy on y. It doesn't matter. Okay? So therefore, the left-hand side becomes a half ln y no, actually, that's not correct. That's not correct. Sorry about that. All right, this is my mistake. This is the integral. All right? And the integral of 1 on y 2y is ln 2y. Is it? I'm a bit rusty at this morning. All right, so it's 1 over 2. All right, and this is e to the x. And the integral, of course, is sine plus c. All right. That's it. That is 4 marks. All right, the next one says Solve. All right. Well, obviously, if the first one was to separate, and this is still not linear, it means we have to make the substitution. All right. But remember, it must be dy dx alone. So therefore, dy dx is equal to 3 right? So our substitution is y is equal to vx and v plus x dv dx. All right. So therefore, v plus x dv dx is going to be 3 x squared plus vx squared over x by vx. All right, once again, I'm hoping that you're working it out and not copying it off the screen. Okay, were you able to get on? All right, so I'm going to go to the top. All right, so now therefore x dv dx would be equal to okay. All right, what's the next step? Anybody? Anybody? What's the next step? Well, we've done all the substitution we could, so there's no more substitution at this stage. Anybody else? All right. Hopefully you're looking at examples we did last week. All right, so at this stage, you have to do your separation. All right, you can leave the tree there or you can carry it on the next side. It doesn't matter. All right, because remember it's x dv dx is equal to, so this x is on the top here, so it goes underneath. Dx is underneath, so it goes on top. V is underneath, so it goes on the next side on top. All right? So therefore, V squared on 2 is equal to 3 ln x plus c. All right, there's one more step. What is the next step? Anybody? What is the next step? Final step. No, that could stay as is. Yeah, you could remove it if you want, but we can leave it there. All right, in this case, because it's 2 multiplied by c, I'm just going to put a instead. All right, once it doesn't involve an x, then you can leave a variable, sorry, a constant there. But there is still one step remaining. What's that one step? Nobody? Come on, guys. We talked about it today as well. You cannot leave V in your answer. You're going to miss out the last set of, whether it's half mark or 1 mark or whatever it is. You have to replace that from here. All right. So your answer is really y squared on x squared, because it's y on x all squared, is equal to 6 ln x plus c. All right, write it down, study it when you get some time. Next one. Okay, so it says solve divide the x. Oh, by the way, that last part was worth 6 marks. Right, of course, this is our method 4. But there's a little thing they say here, as given y is equal to 0, x is equal to 1. Right. Now, unfortunately, when people see this and they don't know what to do, they just go and substitute. Right? And I said this at the beginning. When people don't know maths, the first thing they do is substitute. When you know what you're doing, you worry about this last. That's the last thing you have to do, which is to substitute. So this is in our form. Therefore, P is equal to Q integrating factor is e to the integral of minus 2 on x. All right, but the integral minus 2 on x dx is minus 2 ln x. Right? And therefore, all right, once again, we have to get rid of that minus from there, minus 2. All right, which is 1 over x squared. Substitute, therefore, y by our integrating factor q Okay, so now that we get to this point, remember we want y by itself. So right, we have to multiply everything by x squared. All right, everything including the c involves an x. Right, now people, you're substituting in here, and why do you think you are going to substitute in there? What is the purpose of substituting in there? To solve for what? What are we solving for? C, exactly. All right. So therefore, so substitute and get 0 is equal to 2 plus C. C is minus 2. All right. So you cannot, that's not the answer, right? They ask you to solve given that. So your answer is therefore y is equal to 2x cubed minus 2x squared. All right. If you don't write that, you're going to lose the extra mark or the half mark. Okay, be careful. All right. Everybody understand it? Okay. Okay, let's do another one. All right, so again, this is 2018. And now I'm going to leave you, I'm going to give it to you, and you're going to have to do it. And then I'll check it afterwards. So, all right, so let's go. Now remember, these questions are not in this order. I am doing it in this order for you to practice our methods. But the first thing you're going to have to figure out is which method to use. So it's mixed up on the paper, but I'm giving it to you in order, method 2, 3, and 4. All right, and if I'm not mistaken, we probably did this in class. That's all right, let's practice, let's do it. All right, so dy dx is equal to y squared into 1 plus x over x squared into y minus 1. All right, that's a straight case of separating the variables. So go ahead, give you 2 minutes to solve that. Try something, keep going till you could go no further, or you make a mistake and then stop, and then I will do it. Right, so remember, everything with y goes on the left. All right. In this case, we can divide all right. I'm spelling it out, so when you're revising, all right, see how easy, and you could integrate this. So we're going to get ln y minus, will it become plus 1 over y is equal to minus 1 over x plus ln x plus c. Answer. All right, hopefully you got that. Any questions? All right, so when you are revising for differential equations, revise your integration at the same time, all right? Keep your integration formula sheet handy. And write up some of these things on your formula sheet. So for examination purposes, you will have your formula sheet. We will not give you one, all right? You're not going to get one in the exams. You will have yours to work with. And that same one that I put up on Canvas, you can print it and add all these lots of little this and that to it, so that you don't have to go hunting when for exams. All right, let's take a look at the next question. The next question is, all right, give you a couple of minutes to sort that one out. All right, so let's see. This is, of course, substitution. All right. So it's let y equals vx and dy dx equal to v plus x dv dx. So therefore, all right, got it? Right. So far, so good. And then, of course, the next step would be to separate. All right. right? This we know is ln x. This we know would be minus ln, 1 over 2 ln 1 plus v squared. All right, and this one here is tan inverse, right? You gotta use tan, right? All right, and then of course, don't forget your last step. All right, we gotta replace the v. All right, and v is y over x. All right, so you'll double check this one here for me. I'm trying to remember it offhand. But the answer should be tan inverse y on x minus a half ln 1 plus y squared on x squared. This is equal to ln x plus c. Okay. All right, so here's one last one.
I'm in class. Yeah.
Easy easiest of the lot. Let's see. Solve. X divided dx plus y
on, guys?